Lab 4, Objective 1. Power from the 5 volts pin is wired to the positive rail on the breadboard, and then wired to the potentiometer. The potentiometer uses the voltage divider law to drop the voltage going to analog pin 0, and the rest wired to the negative rail on the breadboard going to the negative pin on the Arduino. The analog read command reads the voltage and then values that voltage from 0 to 1023 using an if statement that anything below 400 turns off the LED. Above 400, a value is calculated and using pulse width modulation to send a rapidly pulsed on-off signal from pin 10 through a 330 ohm limiting resistor to vary the brightness of the LED.
Here we show what analog pin 0 reads as the value changes from 0 to 1023 using a delay of 500 milliseconds to show the values as we adjust the potentiometer.
Lab 4, Objective 2. Positive potential from the 5 volts pin on the Arduino is wired to the positive rail on the breadboard, which is wired to the positive pin and red wire of the line tracker. The line tracker acts like a potentiometer with a variable 0 to 5 volts signal sent from the white wire connected to analog pin 0, and the rest of the voltage sent through the black wire, which is wired to the ground rail and ground pin of the Arduino. 3 LEDs using signal pins 9, 11, and 13, each with a 330 ohm limiting resistor and also wired to the ground rail, illustrating what the line tracker is reading. Over white paper and the white masking tape, the line tracker reads with the white space and lights up the green LED. Over the black tape, the line tracker reads the black space and switches the blue LED on. Halfway between the two, the red LED lights up, indicating that the line tracker is unsure whether it is a white or black space.
Here we show how the serial monitor outputs the data from the line tracker, showing white space, black space, and where it's unsure.
Lab 3, Objective 3. The positive potential is supplied by the 5 volts pin on the Arduino, which is wired to the positive rail on the breadboard. Two 10 kilo ohm limiting resistors are wired to 2 normally open push buttons. The value of digital input pins 11 and 12 are high when the buttons are not pressed, and low when the buttons are pressed. Using if statements, we create a logic that if one or the other button is pressed, the LED turns on. And if both buttons are pressed, the red LED turns on. If neither button is pressed, the LEDs stay off. Lab 3, Objective 4. Positive potential is supplied by the 5 volts pin on the Arduino, which is wired to the positive rail on the breadboard. 3 10 kilo ohm limiting resistors are connected to 3 normally open push buttons, and then wired to a digital pin and to ground. Each digital pin is reading high when the buttons are not pressed and low when the button is pressed. 3 LEDs are wired to corresponding signal pins 2, 4, and 5, each using a 330 ohm limiting resistor and each a connection to the ground rail on the breadboard, which is wired to the ground pin on the Arduino. Using if-else statements, we create a logic that turns red, blue, and green LEDs on if its corresponding button is pressed. But if more than one button is pressed, all LEDs will turn off. Lab 4, Objective 5. The Arduino is wired similar to the last board, with the exception of having a single ground wire and using a 3-colored red, green, blue LED. The red, green, blue LED can be lit using the corresponding colors red, green, and blue, using if-else statements similar to the original 3 LED board. The red, green, blue LED gives us the ability, however, to use logic to create combination colors. With red and green, we get yellow. With red and blue, we get magenta. And with blue and green, we get cyan. Lab 4, Objective 6. Analog pin 0 reads the voltage from the potentiometer, and a value from 5 to 12 is calculated. This value sets an incrementing for loop that will turn LEDs on from none at minimum to a maximum of all 6. A second for loop will turn off the pins from none at maximum to all 6 at minimum.
Here we show the number of LEDs that are on the serial monitor from 0 to 6.